Hello students, in this video we are going to discuss about the Bronsted-Lowry concepts of acids and bases. As the concepts of acids and bases, some of the theories were given, that is Arrhenius concept of acid and bases, Bronsted-Lowry concept and the Lewis concept. From this Arrhenius concept we have already discussed in the previous video. Now in this video we are going to discuss about the Bronsted-Lowry concepts of acids and bases. Bronsted-Lowry concepts of acids and bases. The Danish chemist called Jöns Bronsted and the English chemist called as Thomas M. Lowry gave a more general definition for acids and bases. According to the Bronsted-Lowry concept, acid is a substance that is capable of donating the hydrogen ion, that is H plus ion, and the bases are the substance that is capable of accepting a hydrogen ion, that is H plus ion. So according to this concept, the acids are the substance which is capable, that is which can donate easily the H plus ion, and the bases are the substance which accept the H plus ion. That is the definition given by the Bronsted-Lowry concept of acids and bases. Let us consider a general equation, that is HA plus B negative is giving rise to A negative plus HB. In this equation, HA is donating one H positive to B negative, that result in the formation of HB, that is HA. From this, one H positive is donated to B negative. So at the time what is formed here? It is formed HB. Now in this case, because HA is donating the proton, or we can say H plus, therefore HA is called as a Bronsted-Lowry acid, because according to the Bronsted-Lowry concept, the substance which is donating the H plus ion, that is called as acid. So here HA is acting as an acid, that is called as Bronsted-Lowry acid, and here the B negative is accepting it. So here after donating the H plus ion, now this is turns into A negative, which is now called as conjugate base. So according to this concept, an acid donates H plus ion, and after donating the H plus ion it becomes a conjugate base. Now from this HA, H plus is given to B negative. So now what is remaining here? Now it is remaining A negative is remaining, because HA means how we can split HA? If we can split it into H plus plus A negative. So that means when it is donating the H plus ion, what is remaining now? A negative is remaining. This is called as a conjugate base. Here the B negative is accepting the H plus ion, therefore the B negative act as a base, which is called as Bronsted-Lowry base. According to the Bronsted-Lowry concept, the substance which is accepting the H plus ion, then it is called as base. Here this is donating the H plus to B negative, therefore the B negative act as a base here. So in this case, because the B negative which is accepted the H positive, now it become HB, that is called as conjugate acid. So according to the Bronsted-Lowry concept, the acid is turns into the base, that is the Bronsted acid, I am writing in the short, BA, is turns into the conjugated base, that is CB, and the Bronsted base, that is giving rise to conjugated acid. So in short, the base is giving rise to acid, acid is giving rise to base. Here the acid base pair, that is a Bronsted acid conjugate base pair, Bronsted base and conjugate acid pair. This are called as conjugate acid base pair. Conjugate acid base pair can be defined as the acids that is react to form the base and vice versa. The acid base pair related to each other in this way are called as conjugate acid base pairs. They differ by just one proton. When you look at here in this, the HA is an acid that is with donating the proton, it turns to A negative. So what is the difference in this? That is the difference here is only a one proton difference is there. Therefore, this pair is called as conjugate acid base pair. And when you look at the second case in this, this B and this together, we can see that here it is accepting the H positive to form BH positive. That means here this combination, that is a acid base combination or the pair in which they differ by one H positive. So such is called as a conjugate acid base pairs. Let us take one particular example, that is H2O SO4. H2SO4 is a sulfuric acid that is with water, giving rise to HSO4 negative plus H3O plus. In this, the H2SO4 is donating H positive ion to the water. So it gives rise to HSO4 negative plus H3O plus. That means one H positive is donated. So H2SO4 is acting as an acid, that is Bronsted-Lowry acid, and it turns to, after donating H plus ion, HSO4 turns to HSO4 negative. That is a conjugate base. So this acid base pair is called as a conjugate acid base pair. What about the water? Here the water is accepting the H positive ion. Therefore it acts as a Bronsted-Lowry base. And after accepting the H plus ion, now it becomes H3O plus. So that's why this is act as now a conjugated acid, because the Bronsted base give rise to conjugated acid. Bronsted acid is giving rise to conjugate base. So that pair is called as that differs only by one H positive ion. Then this pair is called as conjugate acid base pairs. So here there is a formation of HSO4 negative and H3O plus. Now how you can easily learn this equation? Just acid is donating the proton to other to form HSO4 negative plus H3O plus. Let us take another example, that is HCl plus water giving rise to H3O plus plus Cl negative. Now look at here, HCl is donating one proton to H2O. That means it is an acid. And after donating the H positive, here only Cl negative remains, that is the conjugate base. So here to here you can see that in this here to here we can say there is a loss of proton. That's why when HCl is given out one H positive, it forms Cl negative, because HCl. How you can dissociate this one? H positive, Cl negative. So when it is giving rise to one H positive, so what is remaining? Cl negative is remaining. So that is what we got here, Cl negative. This acts as a conjugate base. So the loss of proton HCl is giving H positive to form that is Cl negative. What about the water here? Because the water is accepting the H positive ion, that means HCl is donating and H2O is accepting. So H2O acts as a base, and after accepting it, now it turns to H3O plus. You can see here, just add one proton. Proton means H plus. When you add one H plus, it becomes H3O plus ion. that is a conjugate base because conjugate acid because base is turned into acid. So this is what the equation you have to do in this way. Now how H2O become H3O plus? How you make the sum here? H2O. When you add one H positive. So how you do this one? Here 2 hydrogen is already there and 1 nitrogen from here, that is H3, and 1 O is here. So 1 O, because here there is one positive charge on H plus because water is neutral and one positive charge, therefore it develops a positive charge on this one. That's why the sum of these will be H3O plus. Let us take another example like ammonia. NH3 plus water give rise to NH4 plus OH negative. Now look at here in this, who is donating the proton here? Actually the water is donating the proton to ammonia. So that means the water acts as an acid. So after donating H plus ion, because water is having H plus and OH negative, so when it giving the H plus, what is remaining now? Now with the loss of proton, we can say that H2O is turned into HO negative. That means hydroxyl ion H2O is giving the H plus and form OH negative. So here because the water is the donor of proton, therefore it is an acid, and after loss of the proton it is giving rise to the conjugate base, that is OH negative ion. So here the acceptor of proton is actually ammonia because water is donating the proton to ammonia. That means ammonia is an acceptor of proton, so we can call it as a base. So after accepting the H plus ion, it turns to NH4 positive, that is a conjugate acid. So here just add one proton to NH3 to form NH4 plus. Now I will show how you can add this one NH3 and you have to add one H positive. So 1 N, and here 3 hydrogen is already there and 1 hydrogen from here, that is NH4. Now how it comes 4? Because 3 hydrogen is already there in ammonia and 1 H plus you are adding, that's why it comes NH4. This is a neutral molecule and 1 H positive is added. That means there will be one positive sign on it. That's why it comes NH4 plus. So the Bronsted acid is a strong acid, then its a conjugate base is the weak base and vice versa. That means as we have already discussed the acid base pair here, that is the Bronsted acid is giving rise to the conjugate base. So if the Bronsted acid is a strong acid, then it is giving rise to the weak base. And vice versa means, that means if it is weak, if the Bronsted acid is weak, then this one will be the strong. It may be noted that conjugate acid has one extra proton and each conjugate base has one less proton. It can be explained through this example. Now here which one is the conjugate acid? That is H3O plus. So H3O plus, when you compare with H2O, it have one extra proton, and when you compare the conjugate base, that is Cl negative, when it is compared with HCl, it have one less proton. So that is you can identify from this the conjugate acids have one extra proton and the conjugate base have one less proton. Let us see some examples of strong acid and its conjugate base. If the HCl is an acid, what will be its conjugate base? That is Cl negative. First of all, you need to remember this one, that is acid is turned into base, base is turned into acid. That means the Bronsted acid is giving rise to conjugate base and the Bronsted base is giving rise to conjugated acid. So that means acid turns to base, base turns to acid. Now how acid turn to base? By donating the proton. And how base turns into acid? By accepting the proton. So it is important to remember that concept, then only you can able to do such type of questions in which the strong acid, the acid will be given to us, we have to find its conjugate base. So HCl, what will be its conjugate base? That is Cl negative. As we know that acids can donate H plus. So you need to remove the H plus from the acid. So automatically you will be getting the conjugate base. Here HCl is an acid. So it must give H plus. So how you split HCl? HCl can be split into H plus and Cl negative. That means when the H plus is removed, what is remaining? Cl negative is remaining. So that is the conjugate base. Similarly, HBr, the conjugate base is Br negative. Hi, the conjugate base is I negative. What about HNO3? HNO3, how we can split HNO3? You can split in this way, H plus and NO3 minus. We can split this in this way. So after giving the H plus, what is remaining now? NO3 minus is remaining. So that is the conjugate base. You can see NO3 minus. Next is HCl4. So then when it gives one H plus, what is remaining? Cl4 negative is remaining. Next one is H2SO4. H2SO4 have two H positive ion. So from H2SO4, when one H positive is given out, that is one H positive is given out. So what is remaining here? After giving one H plus, what is remaining here? One H is remaining, that is H and SO4, because one positive charge is removed from a neutral molecule. So what it develops? It develops a negative charge. So that is important to remember. One positive charge is removed from the neutral molecule. That's why it giving rise to one negative charge, that is HSO4 negative. So the conjugate base for this is HSO4 negative. Similarly, in some questions, the bases will be given to us. We have to find out its conjugate acid. So as we know that bases is actually accepting the H plus. That means you have to add H positive in the bases. So we'll be getting the conjugate acid. Like the case of ammonia, NH3. NH3, how you make the sum? NH3. NH3. When just add one H positive. When you add one H positive, what it comes? NH. 3 is already hydrogen here and one hydrogen get added, therefore NH4. Because this is a neutral molecule and one positive charge is coming, because it is there one H positive, therefore one positive charge comes, that is NH4 plus. So that is the conjugate acid for this. Next is OH negative. OH negative, because it is a base, you have to add one H positive. Now just add it. When you make the sum, one hydrogen here and one hydrogen here, so total 2 hydrogen and one oxygen is there, that I am keeping here, because here there is one positive charge and also there is one negative charge, that you can see here. This negative and positive get cancelled. So what is the overall charge for this molecule? That is no charge, that is H2O is neutral. So when you make the sum, you have to be very careful with the charges on it. So what is the conjugate acid for this? That is water, H2O. Next, when H2O is a base, so what will be its conjugate acid? So just you need to make the sum, that is you have to make the sum, that is H2O plus, because it is an base, so it accept the H positive, make the sum, that is 2 hydrogen here and 1 hydrogen here, that is H3O, one O is there. As here there is one positive charge here, and it is neutral. H2O is neutral. That's why what will be the overall charge? There is one positive charge. Therefore, H3O plus. When you do for the next one, that is for carbonate ion, the formula is CO3 2 minus. When it acts as a base, it accepts the H positive. So just add it. So one H here, one C here, and 3 oxygen is already there. What about the charge here? Look at the charges here, because 2 negative charge is there on the carbonate ion, and you are adding 1 positive charge. So what is the overall charge? 2 negative and 1 positive, that is -1. So the -1 charge is the charge for carbonate ion. So when you are adding, you need to add the charges also. So 2 negative here and 1 positive here. So 2 minus and 1 plus, that is giving rise to here the -1 charge it is giving. So that is all we have discussed about the Bronsted-Lowry concept. The questions usually arises from this area. So that will be practicing in the next video. So this is all about this video. Have a nice day.